over 175 years, Siemens has been at the forefront of, I'd say, several industrial revolutions. Nvidia is at the forefront of the latest AI industrial revolution, and it's a pleasure to have you both here with us, gentlemen. Roland, I want to try and understand how real this is. You call it an industrial AI operating system. Yes. We're going to talk about how you're joining forces on the software side and the hardware side. But I think the most useful place to start would be, could you outline a timeline for when Siemens goes beyond its own footprint around the world using this operating system to customers actually doing things at scale? Because I think when you were on stage, that's the kind of sense I was getting. You want to accelerate to scale.
Well, I mean, this technology is already in place and it's working. I mean, we see that in many examples, and I brought some on stage today, where you have customers starting with a digital twin of a product they want to manufacture, a digital twin of the manufacturing side, and bring that all together. And not before that, you have it optimized and built in the real world. And AI is already working on the shop floor. They call it machine learning. But the point is, with the new models, you can bring that to the next level. That means you go away from giving an advice to somebody with technology, but really act on your behalf. This is when things go more autonomous or adaptive. And you see that already starting. The big thing is, how can we scale it? Because it requires a lot of skills from our customers, a lot of technology, and it's still not that easy to implement. We are working on it to make it easy to deploy and easy to use. But you see picking up momentum in each step we do, and we saw some great examples. Is it shipbuilding? Is it food beverage? But even startups using our technology, like Commonwealth Fusion Systems.
You know, Jensen, we've discussed the 5-layer cake often. Mm-hmm. You know, with Nvidia, it started with the GPUs, but it's now software. The element of simulation. On stage, you talked about integrating the software side in particular into EDA. Again, it's a similar question for you, more of a timeline. What is it that you think you'll do first in how you guys work closer together?
Well, the first thing, let me just say very quickly, we're announcing a big partnership between us. We've known each other for a long time, but the partnership we're announcing is really a big deal. One, we're accelerating their EDA software. We're accelerating their simulation software. We're integrating AI technology, physical AI and agentic AI, into their team center and their factory automation operating system. And so we're working together across this entire spectrum. When we accelerate the software, then we'll get to use it to design our chips and systems. When we accelerate their simulation software, we'll use it in our AI factories to simulate the thermal properties of our AI factories. When we integrate our automation and agentic systems into their AI industrial operating system, we can then use it in our factory floors with our partners, for example, Foxconn. And so we're working across this entire spectrum together, and we're going to put the technology to use basically as soon as we can.
What's the net effect for you, Jensen? Is it improves margins, efficient capital allocation? I know that might sound a bit dry, but actually right now that's the answer everyone's searching for. How has this investment in AI and use of the technology actually changed things in the real world for me?
Well, we announced yesterday Vera Rubin. It takes 6 different chips to integrate into this incredible system called Vera Rubin. And when you're done, each one of these Vera Rubin GPUs is 240,000 watts. And it is 10 times more energy efficient than the last generation. It is 10 times more cost efficient than the last generation. But it's still, the technology is insanely complicated. 15,000 engineering years came together to build this system. And so when we accelerate EDA tools, when we accelerate simulation tools, and when we can eventually, and I'm hoping very soon, design entire Vera Rubin systems inside a Siemens digital twin, the ability for us to create much, much more complex systems will scale. We'll do it much more efficiently. And so this is really about being able to do the impossible and being able to do it the impossible right the first time.
And let me add, once we then realize that AI creates real-world impact, this is where it really deploys the full power and also the economic power. It's not only in the data centers or in AI factories, which we see, but also on the edge, because once you start inferencing with low latency, you bring this technology to the edge. This is a huge potential for our customers to deploy this technology, and this includes, of course, hardware, where we come from the chips. It goes into the controllers. Some of our controllers run on GPUs.
Yes.
And then it goes all the way to the
call it
hardware
industrial PC.
Exactly.
Yeah.
And we
Now these industrial PCs are AI industrial PCs.
We supercharge it, and they can now run algorithms trained in the cloud. They can run it on the shop floor and do all that trick, what we talked about it in real-time optimization and running in a plant. And that makes a huge difference.
Again,
it drives economic growth.
The question that's being searched for is how is this going to manifest in the real world? You know, the emphasis at this year's CES, I think, is physical AI. Is not the manifestation of the final stage of physical AI just one giant robot that you guys call a factory in the manufacturing context? Is that where you're seeing demand from actual customers? You know, they need a factory that is automated 100% and genuinely autonomous in some degree.
So number one is if you want to build a factory, and very often you're missing out on labor, and we talk about on skilled labor. It's hard to find, number one. Number two is once you build it autonomous and automated, then you have a much higher yield, what you can generate. You use less energy, by the way, at the same time you really optimize it in a way. So therefore there's a lot of benefits. And if you want to talk about the United States, ramp up manufacturing in the United States, you need to go as digital and as automated and AI supercharged as possible.
A factory is robotic, and it is orchestrating robots that are building systems that are also robotic. Like, for example, self-driving cars is a robotic system. And the reason why it's so hard to deploy robots today is because it's hard to program these robotic systems. The software expertise necessary, the customization necessary is really intense. It's just too much. And so the fact that we could now apply artificial intelligence, physical AI technology to these robotic systems, make them easier to teach. You show it a few demonstrations and the AI learned it by itself.
Would you go as far as to say, Jensen, that you've solved for that software limitation?
That software limitation is the ChatGPT moment of it is now here. I think over the course of the next couple, 2-3 years, we're going to make some really big breakthroughs.
Let's please talk about energy, electricity, power supply, call it what you will. In turn, for each of you, how worried are you about it as a bottleneck? And what is your experience day-to-day in running both companies in that respect?
Well, energy should always be a bottleneck for any industry, and this is a new industry that's growing incredibly fast. As you know, AI is both a technology that's going to revolutionize many applications, and we're talking about some of them here. But the AI industry itself, the manufacturing of the artificial intelligence takes energy. It takes energy, it takes AI factories. It's exactly the reason why from Hopper to Blackwell, we increased energy efficiency by 10x. From Blackwell to Rubin, we increased energy efficiency again by 10x. And that translates directly to our customers' revenues, because in the case of an AI factory, whatever factory size you have, you're limited by the power. And that power, within that power constraint, you want to have the most tokens or most AI per watt that you can possibly generate. And so every time we improve energy efficiency, we're effectively improving both the AI capabilities for our customers and their revenues, because they're always constrained by power.
The response to your keynote, and forgive me, Roland, 1 minute, was, you know, Vera Rubin, 10x throughput, really important. Tokens generated at 1/10. But they'll still say, hey, Jensen, what if the electricity's just not there? It's not available.
Well, there's electricity. There's never enough electricity.
And my question is, what is the anxiety level for you both about that issue?
There's always energy. There's never enough energy. And this is every industrial revolution will be energy constrained, and this industrial revolution is also energy constrained. Now, one of the most important things, though, here speaking about the United States, if not for President Trump's pro-energy growth agenda, we would have a very hard time growing at all. In order for a new industry to emerge, you need energy. And so I think it's safe to say that we wish we had more energy in the United States. Europe wish it had more energy. I think the world all wish we had more energy. And so we have to invest in all sorts of different forms of energy. But whatever energy you have, you have to make it as energy efficient as possible. And that's one of the reasons why both of us drive our technology roadmap so hard, because every single new generation of technology is more energy efficient than the last. That's kind of the nature of it.
You are in the AI factory. I won't say data center, because data center is where you store data, but you are in the AI factory supply chain. You must see it.
So what we see is, number one is you see that the energy demand is roughly scaling with the GDP growth. It's decoupling because exactly of this effect that we are providing more and more efficient technology. So that means you are decoupling, but still it grows along with economic growth. And then on top comes a demand for data centers. They demand high quality of energy at the same time, which in some cases creates bottlenecks. Is it now from power generation? And to talk, is it either renewables or gas turbines? There's a huge bottleneck for gas turbines as we speak. It goes all the way to high voltage transformers, to medium voltage and to switch technologies. So therefore, you see along the whole supply chain, obviously, there's a huge demand. We are serving that. There's a reason why this business of ours is growing extremely fast. We can keep up with the demand of our customers, but in some cases you might end up in bottlenecks. If you keep on going as fast as possible, it's a regional dependence. In some cases where you have good programs, good policies, you see that it's catching up along with the demand. In others, you might end up in a gap. But you see the demand is higher than supply chain, and we are ramping up.
It's been the case for a while now.
Which is ultimately the condition we want.
Yeah,
we want a condition where the demand is very strong, because there's great demand for new technology.
Specific to you, Jensen, how severe is the memory bottleneck right now?
Well, the memory bottleneck is severe, but we're fortunate to have worked with all, first of all, Nvidia is the only company that works with all three of the HBM suppliers, and all three of them are major customers and major suppliers of us, and so we had the good fortune of working with them for a very long period of time, and we've got things all planned out. It's going to be okay.
You've been asked a lot about China in the last 24 hours. I'm going to ask you a slightly different question. Okay. What is the attitude of the Chinese government in allowing H200 to go into the country? I understand the position on licenses, the administration here in the United States position, but what does China's government say to you about how they want to approach it?
I haven't spoken directly to them, but ultimately, the way they'll communicate to us will be through the companies. If the companies are allowed to buy Nvidia products in China, then there'll be strong demand, and we're seeing strong demand. And so I think indirectly they've communicated with their companies.
I've learned a lot about Siemens' work in software, and I've always thought the word Siemens to be synonymous with industrial, manufacturing physical things. It's the same lesson we've been through recently with Nvidia, trying to understand actually the software competencies. Is that an area where we might see you be active in M&A? Think about what else you might need that you might not get from the Jensen and Nvidia partnership?
So you might, because we will increase our software competence, our software portfolio. Actually, it's a little bit short of 30 billion, which Siemens invested in M&A to build our software competence, which brings us to the point that
what's missing
today? Exactly. Today we can build the most comprehensive physics-based digital twin of whatever you want to build. Still, there are pieces in operational software which runs plans where you can look into that. AI gives new spaces, obviously. We invested in Dotmatics. It's life science, so it's about molecules. We can imagine doing more there, also in simulation, but also building a data backbone for this life science industry. It's super relevant. We did it for other industries with Teamcenter. We repeat that now with Luma for life science, which is, again, shortening cycle times and reducing costs for life science and drugs and medicines. So, and I mean, the beauty of it is that we live in both worlds. We have the domain know-how. We know how to run things, how to operate, how to automate plans, buildings, grids, trains. And we have the software competence too, and that brings us in a unique position. And then we need strong partners, which have complementary technology, which is so amazing. If that comes together, you see matching things happen.
Well, Nvidia will have access to new technology on the inference side through Groq. I'm going to do my classic, Jensen, could you please clarify for me question, which is this an acquisition or is it a licensing deal spread over time? Because Jonathan and Sunny joined.
We hired 400 or something like that, a little bit less, incredible engineers. and we also license their technology. They designed an architecture that's very, very different than what we've done, and it's focused on low latency token generation. Nvidia is incredibly good at inference, and we're great at training, post-training, as well as the inference phase and test time scaling of AI. And so we've got that space covered. I'm excited about some of the work that we might be able to do together to invent a new segment that might be able to address future use cases. And I haven't described it to people, but the time will come.
So Jonathan is kind of behind the TPU and the LPU, and before all of this happened, there was Groq V2 and V3, and all of that, and it's leading to me to ask, what would that new platform or segment be? What is it that you're trying to build on with those?
I haven't told anybody yet.
But I'm here, Jensen. You can tell me.
I'm going to look in the camera and tell you that come to a GTC conference in the future, and I will tell you all the secrets.
I'm going to make a hard pivot because I have to. Data centers in space. I reported just before the holidays that the reason SpaceX wants to go public.
It's the first GPU in space.
Bear with me. The reason that SpaceX wants to raise $30–40 billion, whatever that is, needs to buy the GPUs. Have you discussed data centers in space with Elon and SpaceX, Jensen?
I can't discuss what I haven't told everybody I've discussed with anybody.
You think it's a viable technology platform?
Sure. I mean, there's lots of energy in space, right? And the cooling is abundant in space, and so the challenges of AI factories are different out in space.
It would be AI factories in space.
Yeah.
Forgive the ignorance almost, but are we literally talking about the same architecture for the GPU that goes into an AI factory, still just being able to go into kind of a satellite form factor?
Yeah, sure, but the way that you would cool it and power it would be very different. And so the system design will be radically different. The chips will be the same.
You're pretty concerned with data centers or AI factories here on Earth. Does Siemens see the need for or viability of such a technology?
I don't know whether we explored all potentials on Earth yet, but there's one beauty in this idea. Think about any kind of manufacturing you want to bring to space. Everything what you produce you want to bring down to Earth. It's hard if you do energy, how to bring it down to Earth. It's hard if you produce any kind of hardware, how to bring it down. But tokens, intelligence, I mean, you can transfer easily to Earth. So therefore, if I would start produce something in space, I would start there.
We should talk about autonomous driving. Have you seen Elon Musk's response to your keynote yesterday?
No. What did he say?
Part one, in short, was, well, we were already doing that. Smiley emoji on X. The other part of...
And by the way, I wouldn't be surprised. First of all, I think the Tesla stack is the most advanced AV stack in the world, and I think the Tesla AV operations is the most advanced in the world, and I'm fairly certain that they were already using end-to-end AI.
Yes.
And whether their AI also did reasoning or not is somewhat secondary to that first part.
I think his point was that the first 99% is hard enough, but the long tail thereafter is important. It's very difficult. The question I got from the audience that was at your keynote was, on a dollar per mile basis, what is the fundamental difference on your stack and your software approach to Tesla's vision-based approach?
Ours is also vision-based. Of course, we have in addition to vision, we also have radar and lidar. But otherwise, the approach is rather similar. I think Elon's approach is about as state-of-the-art as anybody knows of autonomous driving and robotics, and so it's a stack that's hard to criticize. I wouldn't criticize it. I would just encourage them to continue to do what they're doing. They're doing a great job.
Physical AI for you is, and forgive my pronunciation, but Erlangen manufacturing site. When's that real? It's the same question.
I mean, In contrast to the side you was talking about before, this one exists. I mean, we are ramping up. We are automating it as we speak, using technology. I showcased some of that, and we are really deploying step by step now on that very same side this technology we was talking about, the AI brain, the digital twin composer, real worlds. And real-time connectivity to what happens on the shop floor, so you can act and drive basically dynamically what's happening on the shop floor. So, and we will talk about more along 2026.
It's so cool. Siemens is using NVIDIA technology in the Siemens factory.
Yes.
NVIDIA is using Siemens technology in our Foxconn NVIDIA factory. And so, it's a great partnership.
Jensen, you are one of the most important and biggest employers in Silicon Valley. I've been down to Santa Clara to see you. You are a leader of the technology industry right now. The industry and those of us that live in California are reviewing the billionaires tax. The question that a lot of people submitted to me to ask you is, how does that impact that talent pool and the industry and Silicon Valley? Is it something that's of concern to you, or it is not?
I got to tell you, I haven't thought about it even once. We work in Silicon Valley because that's where the talent pool is, and we have offices all over the world wherever there's talent. We have offices. We have office in Germany. We have office in all over the world, and so we chose to live in Silicon Valley, and whatever taxes I guess they would like to apply. So be it. I'm perfectly fine with it. It never crossed my mind once.
I appreciate the answer. And again, it's right now in the technology industry. It's what people are reflecting on. We've had
not really, not this person.
Not this person?
Yeah, this person is trying to build the future of AI.